Okay, this lesson should explain the surface area of a circle. We found out about circumference and pi, so now we're going to do surface area. So sometimes we have a circular object where we need to know what the flat surface area is instead of just the ring or the circumference. Okay? Now when we want to measure the surface area, we're going to come up with an answer in square units. Like if these were inches, square inches, or feet, square feet, or centimeters, square centimeters. Okay? Now, to find out the area of a circle, there is a particular formula. And that formula for area of a circle is the radius squared times pi. Another way to say that is the area is equal to the radius times the radius, which is radius squared, times pi. Now usually in a book you'll see the formula like this: area equals pi times r squared. But so many times on tests you'll see the number come first, so that's why sometimes I put the radius first. Okay? Now, let's take a look at our first example here. All right? Our first example is we have a circle. It's filled in like that. The radius, let's say, is 2.5 units. Okay? So here's the question. What is the surface area of a tabletop with a radius of 2.5? Okay? 2.5 is like 2.5. Now let's remember that area is equal to r times pi. All right? So if we're going to figure this out, just put that right underneath there. If we take 2.5 squared, that's like 2.5 times 2.5. So if we want the answer in terms of pi, it would be area equals 6.25 pi. So if we just go right back up to here, the area in terms of pi is simply 2.5 times 2.5 pi. That squared is 6.25. Now, if we want to assign a number to pi, like let's say the decimal pi is 3.14, well, if we know that area is equal to 6.25 times pi, then area is equal to 6.25 times decimal pi, and then this would be the area, 19.625. Now, let's see how that might work out on an example like this. If we take its widest point for the diameter here, it's exactly 5 blocks over. So the radius would be about 2.5. Okay? So this is a circle with 2.5 radius, and let's see if it comes out to about 19, a little bit over 19 square units. Okay, now watch this. 1 square unit, just about 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now let's go 15. Let's go 16. 17, 18, 19, and maybe another half, about 19 and a half. And look how close that is to the actual area here. Okay? So I'm hoping this example kind of showed your mind how those square units work. Now let's go to 3 other examples. So Here we have a radius of 5 with, let's say, a tabletop. What is the area of a tabletop with a radius of 5? Okay, well, the formula is area equals pi r squared. Pi times 5, area equals 25 pi. Now this yellow underline area may be the type of answer you see on a test where they only want the area in relation to pi. But if you wanted to get an actual number out of this, you'd take area equals the pi number, 3.14, times your 25, and you'd get about 78.5. Okay? All right? And that'd be 78.5 square units. Now our next example gets a little trickier here, like on a state test. What is the surface area of a circular pool with a diameter of 14? Now, maybe on this test, they're not going to give you a circle. They say a circular pool, and then it shows a diameter of 14. Now, how are they trying to trick you here? Our area formula, it does not need a diameter. It needs the radius. So, since it gives us a diameter of 14, we would say that the radius is half of the diameter, and half of 14 is 7. So 7 is the radius. Now we go to our formula. Area equals pi r squared. Area equals pi times 7 times 7. Now if the test just wanted the answer in relation to pi, area would be equal to 49 pi. Now if the test wanted the actual number, we would say that 49 is divisible by 7. So since 49 can be divided by 7, we're going to use 22/7 instead of 3.14. Because then when we take our r squared times our pi value, then we can go ahead, cross cancel, and we get exactly 7 times 22, which is 154. Okay? So another kind of tricky problem, another kind of tricky problem might be something like this. We have a little circle within a much bigger circle, and so we have to find the radius of this donut-like, we have to find the surface area of this donut-like object there. Now let's say the smaller circle has a radius of 12 right there. And then the bigger circle from the center point clear out to the side has the radius of 25. So what we're going to do is we're going to take the big circle area minus the small circle's area, and that should give us this donut shape here. So maybe on the test it says, what is the area of the shaded donut? Okay? So the big area, we need to subtract the small area from the big area to get the area of the donut. Now the big area is 25 squared times pi, which in terms of pi is 625 pi. Subtract 12 squared pi, or 144 pi, which leaves us with the area of the donut as 481 pi. Now, if we want to convert that to a number, we would take 481 times pi at the decimal, 3.14, and we come up with 1,510.34 square units. Okay? Now our last page here just quickly goes over what we call technically correct area answers. They will always be equal to units squared. So like square feet, square meters, square centimeters. So in our first problem, we took the area of a tabletop with a radius of 5 feet was equal to 78.5. But the technical answer is 78.5 square feet. So feet to the second power is called square feet. Our second problem was, what was the surface area of a circular pool with a diameter of 14? It was 154, but the technical answer is 154 square feet. And then our last one, the area of the outside donut, it was 1,510.34 square feet. And we write square feet as feet squared. If it was centimeters, it would be cm with the raised 2. Okay? I'm hoping that was a good lesson.